Welcome to the GridWise Architecture Council's video library. The following presentation by Shawn Chandler is entitled DER System Evolution at the Grid Edge with DLT and was presented to the GridWise Architecture Council on February 19th, 2025. Welcome, Shawn.
Yeah, thanks so much, Jamie. Hi, everybody. I'm a director at Guidehouse. Been on the council, as Jamie said, for a year. I've been in the industry for 30 years and in a number of utility roles. I'm the solution lead for Guidehouse for the Western region. And yeah, I've been working in data analytics, IT/OT, grid architecture. I was an enterprise architect for many years at Portland General Electric, and then moved over to PAC, Pacificor, and Berkshire Hathaway Energy, where I ran data analytics for all of Berkshire Hathaway Energy across all their operating platforms. Following that, I came over to consulting. I am, in the regard to this talk today, I am a big proponent of IEEE standards, and I've been working in the standard space for, gosh, almost 20 years now. And in the standard space, I've held a number of roles, mostly at the grid edge. I was the founding chair of the Smart Buildings, Loads, and Customer Systems, soon to be renamed Grid Edge Technical Committee. Technical committees, as you may know, inside the Power and Energy Society are that fabric in which IEEE works to promote standards, develop standards, and sponsor working groups that goes up through the Standards Association. So I'm the chair of the Interoperability Task Force in one of those standards, P2418.5 Blockchain for Energy Standard for the power industry. And blockchain itself is a technology. I'm hopefully going to clear some of that up today, talk about it as a technology. It is not just used for cryptocurrency. It is a very interesting technology, which is all about distributed systems. And as we move towards distributed systems in the grid, so be it that we will need distributed systems and distributed system platforms to engage most efficiently and effectively at the edge of the grid with all the resources that are out there. And most importantly, in order to optimize grid operations to the best extent possible, seeking out that typically very difficult to achieve equilibrium, the Nash equilibrium, where no player in a grid optimization may act without harming any other player. So it's the most optimal state. You can only get that with nearly perfect information, or at least as much information from the edge as you could possibly handle. So we're going to talk about blockchain today as a technology which has the capability to impact our industry in ways that may have been previously not considered. And most importantly, as we move forward in the evolution of the grid, that it should be considered, in fact, as a technology, as a platform for engaging with a number of entities. And I'll talk about that more. Go ahead and let's advance the slide.
Oh, I had you sharing. Do you want to share your own screen?
Yes, I could do that. Give me a second here, and I can do that. I am going to go off camera because this is on a monitor where I'll be looking up, and nobody likes to look at that. Just 1 second. Sorry for the delay. Okay. All right. Let's just go ahead and advance. So here, starting with the background, I want everyone to see this. This is from Tech Target. I want to make sure that I'm you know what, let me go back just one slide here. I just want to say special thanks to IEEE, specifically to the IEEE 2418.5 task forces, the one that I led, and then all the other task forces that have been involved. This was a very long effort. It's been around a long time, since 2021. We've been working hard on it for 4 years. A lot of effort has gone into the development of this standard, which is set to be released within the next few months. And then also special thanks to the 2025 Grid Edge, where I talked about this, and I've drawn some of the materials from a presentation I gave at the IEEE Grid Edge conference. All right, proceeding quickly. Distributed ledger technology, there's centralized ledgers, and then there's distributed ledgers. We're going to talk a little bit about that so that I can hopefully demystify the use of a ledger. They've been used for thousands and thousands and thousands of years, ledgers. The first mention of a ledger goes so far back that it's really in the age of antiquities. We're talking about clay tablets. And so when you write something down, why do you write it down? Because you want to know what it was and you want it to be transparent to anybody that reads it, what you wrote down. You want it to be traceable. You should know what it was talking about, and you want it to be trustable. That's why we write things down. So a distributed ledger is just a way of doing that very thing, and we're going to talk more about that. So when we think of the background for distributed ledger technology and distributed energy resources, and again, I'm putting this all in the context of a future grid where we have distributed energy resources, which are acting a little bit differently than our centralized generation does today, where we can optimize on the fly. We're doing it at the circuit level. This is a future that we don't have yet, but it certainly has been considered. Here we have the NIST framework for smart grid interoperability standards, which comes from NIST, obviously, and this is a 2021 version here. You can find the reference below. We think about centralized systems. We have to have control systems and system operations, and we have ISO participants on the market side. And then we have these pillars of customer, which are now extending over into distributed assets and then edge devices. So we have customer, distribution, transmission, generation, markets, system operations, and control systems. And when we think about that, what are we really trying to get to? Why do we structure an architecture in this way? And it's because we need all these entities to exchange data. This is all about the ledger. We have to have control, and we want to write things down about how we controlled and how we plan to control and the rules for control. We have regulators who want to know how we've controlled, what we plan to control, and whether or not we're matched up to the rules for that control. And then we have asset owners and aggregators and a variety of other participants that may be in this system, industry stakeholders and so forth. Customers are certainly in that system. And so when we look now then at this system, we really should be designing the system for the most efficient and effective data exchange and to write the data down. We've got a communications network. We have roles for all these actors. And then we have a gateway role. So how are we going to get information to all of these parties in the most effective way? Well, if we jump over into the Sanelec model, the smart grid architecture model from the Reference Architecture Working Group, and again, this goes way back more than 10 years, and we consistently have thought about the interoperability dimensions in this system for that same amount of time, 10 years. There are so many models and methods of interaction in our industry which are dependent upon this model, and it depends on these things. Business layer. This is where we have all of our business objectives. We've got our functional layer, which has all the use cases and how those sub-functions may interact between the business layer, where we have our business objectives, and our information layer, where we have our data models. And then the information layer, as just mentioned, and then the communication layer, which has to make it all work. We got to send all this data back and forth between all these parties. And then way down at the component layer, we have all of our different parties that all need to communicate up and down through this stack in order to get transmission, generation, distribution, all the DER and the customer premise domain. Those all have to work effectively with each other, as you can see over on the NIST model. And then you have to have the processes. So what's working in the field, what's working in the station, how is it functioning as a total operation, how does it come together as a system of systems in the enterprise, and then how does it engage with the market? So enough on that. It's important to think about why this background applies to our industry and how it's been evolving over time. And most importantly here, that DLT, the distributed ledger technology, don't want to say blockchain because it immediately brings up these images of cryptocurrency. Let's talk about distributed ledger technology, DLT. And what does that do? DLT combines the business layer, the functional layer, the information layer, the communication layer with a set of rules down at the component layer in the same platform that can be engaged through both automation and transparency, trustability, traceability, all in one place. Not many systems can do that. And so that's why we're giving it a lot of attention in this standard. All right, moving forward. So DLT combines those interoperability layers in a single technology, let's talk about how that is played out for what we care about in our industry. So first, on the left, our functional capability and our process automation, we have condition-based processing. Digital ledger technology has, distributed ledger technology has condition-based processing. They're called smart contracts, and a smart contract has an objective function and a constraint and anything else you want to put into an algorithm. It creates a code-based processing guarantee that is built into the data at the moment that the data is received. I'm pausing for effect. That's very interesting. You don't need to send data up and down through the stack in order to get to your processing layer, transfer it from one system to another system. You can build it right into the database layer. So as soon as data is received and written into a chain, your smart contract automatically functions because it's watching all that data the instant that it arrives. And that's very interesting, condition-based processing. Second, traceability. Inside of a distributed ledger, you know every single transaction within minutes because it's been written and then copied out to every single other member that is inside of that system. And when I say it's a member, we're going to call it a node. A node can be controlled by, and I'm going to go back one step here just to hammer this in. All the entities in the system can sponsor nodes. You could have customer nodes, you could have distribution nodes, you could have transmission nodes. Nodes can be anywhere. So a node can be both an actor and a node can be at a device layer. You get to decide how you do that. We're going to talk about that later, briefly. I don't want to spend a whole lot of time on this, but I really need to demystify. It's very important to demystify what blockchain is from a cryptocurrency perspective that everybody thinks of and nobody trusts in the energy industry because of how much energy it uses. We've got to go back to thinking about it as a technology. So that's why we're spending all this time here. It's got to be traceable. So data should always be traceable. Anytime you write something down, you don't want to hunt and peck. Well, where's that notebook? I wrote that down in 3 years ago. If it's in a blockchain, it's pretty easy to find. It's searchable. You get a record of every DER state or any other asset that you want to manage or anything else you want to write down. You got a record of it, an action, a data source, and a timing. You can align it to market alignment. You got a time and a date stamp in a ledger. That's very interesting for us because our industry works on time and date stamps, 8,760 hours in a year. We all know how that works. You start to get into 15-minute modeling and 5-minute modeling, and now 1 minute someday far away in the future. It's got to be traceable. So because you can have that knowledge at every node, every single node has a full copy of the entire database. Now, I gave this presentation in the context of 5G and 6G at the Grid Edge conference. And I'll tell you, 5G and 6G, you start getting into 20 gigabits a second, you can really start moving that data around. And all of our issues with moving around large amounts of data really just get washed away. Finally, in a DLT, a distributed ledger technology, you have security. It's all encrypted. The process automation is encrypted. Every node can transact directly with every other node participant without revealing their identity or revealing their identity. If you want to do it that way, there are options for how to do that. The key is that it's secure. And I'll talk just very briefly about that. It's done with a cryptographic hash. And a hash is just a limited number. It has a prescribed amount of digits that can describe any length of any number of digits. Hundreds of millions of digits, you can put it in one length of a hash. And so what that means for that security, because it can be hashed, is that nobody can change any amount of data in the database ever because the hashes wouldn't match. No node can create their own version of the truth. Once the truth is written, it can only be written once. And that's where we get over into the right-hand side on data management. I'll jump over to that. Because of the redundancy, you can have this TCP/IP network system, super high availability because it's distributed, has low risk with full distributed copies of the database. It's trustable because of that encrypted storage that every value in a block, in a single block, is hashed. You can't change it. It's immutable. Data can never be altered. And then finally, you've got all these access controlled operations. You can't act in the network. There's no function for a node that hasn't been allowed into the network. You have to join the network. And so therefore your access is controlled and anything that you can look at is controlled. And so it's very trustable. And then finally, it's transparent. We only recommend in the standard that you use permissioned distributed ledgers only with proof of authority. That's a consensus method. I'm not going to talk too much about consensus methods today, but just a little bit, and I'll do that on a future slide. You got to have access to historical records. This is great for regulators. It's great for aggregators. It's great for utilities. It's great for customers because you get access to all your data. And it's written once. So the first time it's written, you have access to that data immediately. You don't have to wait for someone else to come in and do measurement and validation of the data because it's written one time and it's written in the format that the ledger will accept. And I'll talk about that on my next slide. So what are the applications here for these distributed ledgers? Very briefly, a little bit about how blockchain is broad, what's happening with the momentum of blockchain. Well, in the state of California, which tends to be first in many things in the energy industry, Executive Order N922 established a system of evaluation to incorporate blockchain into state operations. That got done years ago now. And so all these agencies all over, yes, sir. Was there a question? I see someone pointing at something. I'm just pausing.
Yeah, I don't think so.
No, just pausing. Okay, very good. You've got an interesting order here from the state of California looking at blockchain technologies and how you can incorporate them into state operations. So that's a push. And then on the market outlook, and this is a little bit older, I'm just talking about the current state that, you know, the growth, we had 34% up through next year, 37% from another group that was looking at it. You know, I've got my sources down here. And again, these are older. These were from a few years ago, but I'm just trying to give you an estimate of, you know, how's it growing? You know, we're looking at billions of dollars, not hundreds of millions. You know, there's supposed to be a lot of growth. We're not seeing this yet. I'm going to say that the growth is really expected to reduce transaction costs. And in my opinion, this is an opinion, it's not analyst based, it's my own, is that the mistrust of cryptocurrency and then its treatment in the market has slowed the uptake of this technology in the energy industry. And this was all specific to the energy sector. Let's keep moving forward and talk about the use case benefits. Again, this is the applications for it. It's a new technology in our domain. It's been used a little bit. There's companies out there that are doing it, very few, but a few are there. It's really about the grid and the customer and how we're going to manage it. So when you think about the grid, you got to have real-time pricing. That's a goal for many utilities. Many utilities, they want virtual power plants. You got to be able to bulk up systems of reliable assets on the fly. You want to do it in response to market conditions. That's done by our fighter pilots in the energy industry on the power marketing group and our other fighter pilots in the industry who are sitting in distribution operations and transmission operations. Those fighter pilots need the best tools. They need the best planes. So you want to give them things to be able to move these systems around fairly quickly and make new rules for how they're going to interoperate with all the other systems. That's around capacity and asset optimization. It's around frequency regulation, and it's around voltage and VAR support. That should be clear to everybody on this call. On the customer side, it's really about how am I going to get my demand charge reduced? That's what customers care about. They don't want to pay as much money. And it's about self-consumption. How can I use my resources for myself when I want and give them to you, and then I get a little something for that? And then it's also around microgrids and reliability applications where customers are joining together to create higher reliability as groups. We tend to call those microgrids. There's other names for them, but these high reliability applications, you know, there's power safety system shutoffs because of wildfire. There's lots of reasons that a customer might want to do something on their own. And you need to inform everybody in that top box up there on the grid side. You need to let them know when you're going to do that. And you need to do it in a really in a very reliable way so that it's transparent and traceable and trustable. So with a distributed ledger technology, these grid management tools are enabled, and you got to have near real-time communication for that, but it gives you a new layer of automation to do all that, transparency, traceability, and trustability. So let's move on. In the system design, you got to be careful with this. because there are three things that come into effect that will impact the performance of the system of systems. The first one is the network. The second is what consensus you're going to use to get everybody to agree on what's going to get written into the database. And the last one is the node design, the number of nodes, and then what kind of communication paths they have and how you're drawing together all the data. So first on the network side, you can have wireless networks, that's fine, 5G, 6G, plenty of bandwidth there for off-chain communication hosts. And these hosts are called an oracle. This is an important concept. I'm going to just pause here for a moment and talk about that. An oracle is the device that takes data from a sensor, from a device, and I'll talk about those devices later. I'll show you all the different kinds of devices. It's a little bit biased because I'm thinking about DER here, but it could be anything. But you can't just put data onto a distributed ledger by yourself. We're not going to embed this capability into all these devices. I just, that's a big headache, and you can think about the supply chain curve, and as things proceed from very difficult to do in the early days of innovation to very easy to do as cost comes down, that logistic curve, which has, this is a matter of physics and market participation that has proven itself over hundreds and hundreds and hundreds of years of innovation. We're talking about something here that you just don't want to push that out to every single device. You should have devices that do it for all those devices. And the reasoning for that is market-based, and it's also innovation-based. If you think about the way that the internet evolved, you had one way of doing things. You had one protocol, really, that could make it all work. And so innovation proceeded very, very quickly. So that's at least my opinion there, that we should be using oracles. We shouldn't try to embed this capability into every single device. But if an oracle sits between a device and the network of the nodes, and so your preferred node and oracle location is going to vary based on functional needs. Is it behind the meter? Is it at the substation? Is it somewhere else? Is it, you've got NERC considerations for critical infrastructure protection that you have to consider. You've got other considerations clearly for six-walled protection around these types of devices. If you're going to put it in a substation, control room, and other locations, then that's fine. But if you're going to put it behind the meter, all of a sudden you have to have special capabilities of that device. It can't be tampered with, it has to have special certifications and so forth. So, special chip designs, you got to be careful with your network system. Okay, so oracles, they put data onto the network. Then you have to have considerations for the bandwidth. So the better bandwidth you get better block rates. The number of blocks that can be moved through a system. Block rates in a cryptocurrency system are a couple blocks, a few blocks per second. You don't get very many. But with a different consensus method, and particularly a consensus method like proof of authority, and there are others that I'm not going to talk about today, but in proof of authority, you can get your block rates up to even 10,000 transactions a second. 10,000 transactions a second. Now we're talking Visa, MasterCard transactions per second, and the whole network of all of the credit cards around the planet. They're working at, hundreds of thousands, millions of transactions per second. So you're getting into a transactions per second with a different type of consensus method. Specifically these proof of authority methods that you can increase your block throughput and get into something that is sufficient for the energy industry. So you do need good bandwidth, but you have to make a choice between network system and consensus. The better the network system, you just want the absolute fastest network you can have, and then you got to be careful with your consensus method. And then you also have node synchronization, how fast you can move data from the nodes that are doing the consensus to the nodes that may not be involved in the consensus process. All right, so then you have consensus methods. We do make recommendations in the standard, and then proof of authority is generally the one that we're going to recommend because it allows an authority to be established that gets to decide what data is going to be written. It's not up to every node. There's no mining. There's no cryptocurrency methods here. It's the way that utilities work today, which is that there's a centralized authority, and that authority is written into a node, and those nodes could be anywhere. So as long as those nodes are protected, then those nodes can work with that method. All right, I'm going to move forward. All right, so now let's talk about the standard itself. We're getting close to wrapping this up. So the approach of the standard working group, again, just a little bit about ancient history here. It was formed in 2021. What was our goal here? Well, we went in to evaluate the domains and the building blocks that would be necessary to develop a standard around this technology. Two, we started looking at reference frameworks and architecture, and we defined segmentation of the industry into parts so that we could address it correctly according to NIST and Smart Grid Architectural Model and other models. Transactive energy was a really big consideration in developing this approach. Certainly in my group it was, and in others. We had folks who've been part of the transactive energy family of proponents that were deeply involved in the development of the standard. Then we got into terminology and ontologies and the acronyms of the technology, and we addressed that. And then we looked specifically, and now we're getting more into the interoperability of it because this is where I focus. Again, I was the chair of this task force, so we had to look at other interoperability frameworks and security frameworks, and we looked at how it might be used. And then we classified and validated these use cases. We went through a verification and validation. Are we looking at the right use cases? That's verification. And then validating the use cases themselves with, a peer review of folks. And there were, more than 75 people in this standard. So it was a big standard, considering the way that IEEE standards are usually staffed by the folks who are able to contribute. Again, IEEE is a wonderful organization, and it's a lot of volunteer time, just like this one, just like our own. In terms of functional requirements, we had to look at semantic interoperability. I'm going to talk about that a little bit on the next slide, so I'll skip that for now. Then we looked at subsystems, all the key actors and the interfaces for every use case. So you can see this was a very predictable method of going through our process. It's predictable because this is the way that most system analysis is done in the industry for at least 50 years. For those of you who are out there who are into systems science, this is a nice way of breaking a system into parts and then breaking it into smaller parts and then looking at all the actors and the interfaces. And then, of course, we had to harmonize with existing DLT communication standards in the IoT space. Just a little plug for the Internet of Things magazine, on which I'm an associate editor for the energy domain. All right, let's skip over here to interoperability and take a very brief look at this. So when you think about interoperability, you got to talk about the device layer, the syntactic layer, and the semantic layer. That's the way it's done. And this can be drawn out into a larger, and I've drawn a little diagram here for us that you have connections and communications. That tends to be in the device domain. You've got communication and meaning. That tends to be down in the syntactic domain. And then all the dynamics, a little bit of the meaning, and then all the dynamics and the behavior, and then the conceptual, how is this thing going to function? That's all up in the semantic domain. And so we broke it into 3 domains, and then we started developing our models. Blockchain interoperability, and this is directly out of the standard, is the ability of distributed ledger computing systems to interconnect multiple intra and inter DLT blockchain and DLT enabled power and energy systems and their subsystems to create, transfer, register, and validate digital energy information, the services in this domain, the assets and the transactions. And again, it's across multiple ledgers in a secure, scalable, trusted, and administered consensus approach. All right, moving forward, let's just take a really quick look at the domain model. There's an operational technology domain that all of us are very familiar with, all the processes and transactions for grid operations, mission control, critical control processes, and then, of course, the automation and supervision that we all know is needed and necessary based on our operating mandates from FERC and NERC. And so, and certainly within public utility commissions at every state. So the utilities need to operate the grid. So we have a special domain for that and how they'll operate in there. And then we've got enterprise IT. Enterprise IT and OT, they're often considered separate. There's a little bit of, maybe the jury isn't totally out yet on how IT and OT vacillate, back and forth with each other in the utility domain. But it's certainly something that we felt was necessary to draw it out, that IT for the enterprise operation and the cybersecurity of the systems and the data management of those systems, we thought that that deserved special attention. So we put IT in the middle. And then we've got customer-facing DLT. That has to be special because we have to allow these DER and customers to see what they're doing. There's special processes and transactions for services between the interaction of operational technology and the market and the customers and the IT. And then finally, in the market itself, we've got, ever since FERC 888 and 889, we've got markets. And so you've got to think about the processes and the transactions that are related to the wholesale market services, as well as other new types of markets, and then the service orchestration that's necessary to draw all this together. All right, so I promised a device segmentation. This is non-exhaustive. Gosh, I've used this slide for so many years, maybe almost 10 years now, thinking about these slides. I just keep remaking it. You're seeing a really old version of Microsoft Office PowerPoint. The pictures here, some of you will recognize those from days gone by, but all these, it's updated for our transactive energy future here. We've got things in the energy technology space, renewables, that's really important for blockchain, grid-tied energy storage, very, very important, certainly with data centers and other stressors in the grid system. We need energy storage. That ties right together with renewable assets right up there at the top. Microgrids, those assets and systems, and then distributed generation as a whole. On the transportation side, there's no one in the room that doesn't recognize the issues that our industry faces and the challenges of electric vehicles and the electric vehicle service equipment that joins them to the grid. Then on the utility transformation side, we've got all the grid IT, OT that's always changing, AMI 2.0 and sensors. AMI 2.0 is interesting because it can integrate with devices behind the meter in the home and pull it out across the network. That's if your AMI can talk, not in a mesh network, but let's say in a 5G or maybe even a 6G context in the future. All the T&D sensing, dynamic line rating. This is really important because of the, that recent decision about dynamic line rating. That goes into effect this year. I think it's in July. Certainly all the automation that we're looking for in the distribution grid, that all comes into play here. All the customer side devices, peer-to-peer networks. I'm not going to talk too much about that. And then network orchestration, obviously, you got to be able to orchestrate your network of devices. It has to work between wholesale power side, where generation is very considerate of what is happening in distribution, but that's set forth in the day. That's done on a daily basis in a morning meeting with power marketing, when generation sets their operating mandate for the day forward, and then things don't change unless you need to move that power plant around. But network orchestration is certainly a big consideration. And then finally, when you get down into building innovations, we got to make it work with all the building management systems, all your BMS and everything that's happening in that domain, HVAC, building envelope considerations, how you're going to build these buildings in the future and manage them, all the air chillers, everything that's happening in the smart building space. And then smart cities. That's really interesting in this environment for DLT, because you can start to talk across agencies. It doesn't just have to be the utility. You can start to look at street lights and traffic and other things that may also be important in our domain of interest. Certainly with field operations, you get a tree down and you knock down a power line and you want to tell the city and all those other agencies that there's something going on. You can link that all together with a distributed ledger. So there's lots of things going on here with distributed ledger functionality. The entire system and the system of systems is driven by all these complex interactions and feedback between all the stakeholders that are in all these silos. And I could go back to slide 1, but I'll just say it. It's all the regulators. It's all the utility participants. It's all the customers. And it's all the other stakeholders in this system. Everybody cares, and you can get all that information to them in minutes. All right, so use case alignment. Let's just take a really quick look here. That when you think about the smart contract processes, and we're getting very close to the end, smart contract processes and data ledgers. So in the operational technology space, you've got your grid operations and the attribution of the mission critical process control, automation, and supervision during events. That can be linked to system management of DER. It can be linked to T&D grid management, and the integration of aggregators as pockets of aggregators that may have control, You might have different aggregators. Utilities love to write separate contracts with different aggregators, and different aggregators may be mixed into the same circuits. And so you have to have visibility into the DER at the grid edge so you can use a ledger to ferret that out with a smart contract process. That's interesting. And then also a little bit onto the customer program side, but that has to come through IT first. I'm not suggesting, and I'm going to be very careful here, I am not suggesting that we're going to put all of our OT inside of distributed ledgers. That's not going to happen. Now, maybe in some day in the future where we have some ubiquitous treatment of this technology, maybe that's a possibility, but this isn't in the near-term future. That's got to be at least 10, 20 years away. So let's not leave the room in a panic thinking that somehow, distributed ledger is going to be a solution there. It's not yet. Because the timing isn't right. You got to have sub-second management and control, and that's just fine and good for EMS, OMS, ADMS. Let's leave that where it is for today. But you should think about it. Maybe there's some things that we can integrate with those systems that might be in this system of systems. On the IT side, lots going on with IT enterprise operation, the cybersecurity and data management, specifically to vehicle grid integration. This really reaches across the stack for IT. It's vehicle grid integration, how are you going to get aggregators and charging and integration of all your customer functions. There's lots there with vehicle grid, V2G, V2X really. And then on the T&D side with clean electricity tracking, you need lots of different departments need that information inside. Besides, things are coming from T&D, but need to be spread out across all the different folks in a utility. And then, so you push that through enterprise IT as a service. And then the customer programs, the system management, and the GHG attribution, these are all really important factors. So you push all that through IT. And then you might have aspects of that are customer facing, your energy efficiency management. That's really important, certainly for folks that are managing energy efficiency. And there are lots of alliances out there that do this. And they work with utilities and the state public utility commissions for funding and getting programs out there. There's lots of value there. Billing, settlement, energy service provider services, lots of things you can do in smart contracts and data ledgers there. And then, of course, the market. This is closest to what distributed ledger technology was originally intended for, which is a way to move money around. So it's got a native capability in that. All right.
Thank you, Shawn, for that very interesting presentation. For more information about the GridWise Architecture Council, please see our website at gridwiseac.org. And don't forget to subscribe to our YouTube channel at the site listed. Thank you.